Right, problem 3 says to determine whether the function is linear, exponential, or quadratic, then write a formula for each function. Okay, so for part A, notice that x is increasing by 1 as we go from point to point, and y is increasing by 3 from point to point. And so since we're repeatedly adding a fixed value, 3 in this case, this is a linear function. And to write down an equation for this function, well, the slope m would just be the rise of 3 divided by the run of 1. So in other words, it would just be 3. So it would be 3x. And then for the y-intercept, notice that's right here. B would just equal 5 there. So 3x plus 5. And you can easily check by just plugging in values of x. So if I plug in -1 for x, I'll get -3 plus 5, that's 2, that's good. If I plug in 0, I get 5. If I plug in 1, I'll get 3 and 5, that's 8. Plugging in 2, you'll get 6 and 5 is 11, so it's working. All right, cool. So how about for part B? Well, again, x is going up by 1 from point to point. And then for y, notice here I have an increase of 1 unit, but then here I have an increase of 1.5 units. So since, right, these are different changes, I do know that this thing is not linear. So then we could ask, well, is it exponential? In other words, is there a multiplier that takes us from one output to the next? Well, and to see if there is such a multiplier, let's look at the ratio of successive outputs. So in other words, if I look at, say, 3 over 2, that's 1.5. And then moving to the next pair, I'd have 4.5 divided by 3. Oh, well, that's 1.5 still. That's good. And then if I look at the next pair, it'd be 6.75 over 4.5, and that's also equal to 1.5. So the answer there is yes, there is a multiplier, in this case of just 1.5, as I go from output to output. Okay, so that's saying, since I'm repeatedly multiplying by the same thing, that this is exponential. And then to write down an equation for this, well, the initial value, the a value, would be, just like we saw here for the linear case, it would be 3. So I'm going to have 3 there, and then I'm going to have my multiplier there of 1.5, and that's going to be raised to the x power. Okay, and like for the linear, you can plug in the values of x. The calculations are a little more complicated now, so you could use a calculator, but you can easily check that this does do the job. All right, and so then for C, well, here x is still going up by 1 unit from point to point, so we still have that. And now here, well, I could see that I'm going from 3 to 12 and then 12 to 27, so that's not the same change, right? I'm going from change of 9 to 15, so it's definitely not linear here. I'll go ahead and say this is plus 9 and this is plus 15, right? So it's not linear. You could go ahead and check and say, well, 12 to 3, 27 to 12, 48 to, right? There's not a constant ratio, so it's not exponential either. So it ought to be, according to the wording of the question, quadratic. So then how do I find an equation in the case that it's quadratic? Okay, well, what we do there is we look at what's called the second difference. Okay, so The first differences are 9 and then 15, and then this is a change of 21. But now if I look at the changes in these changes, so in other words, going from the 9 to the 15, this is known as the second difference. That's a difference of 6. And then here from 15 to 21, that's also a difference of 6. And so for quadratics here, these are going to look like y equals ax squared. The key here is that we have a constant second difference. And what I'll say here is that later on in this quarter, we are going to review quadratic functions in a lot of detail. So if this doesn't feel particularly familiar, don't let that bother you too much. The questions on the web assigned homework are very, very similar to this one. So you can basically just do the same kind of thing. And like I said, we will review all of this in more detail later on. Okay, so then since I do have a constant second difference, in this case of 6, how do I go about finding the a value? Well, turns out that the a value is always half of whatever that constant second difference is. So in other words, I'm going to take this 6 and divide it by 2 to get 3. And so you put that all together and your equation is going to be y equals 3x squared. And here I'll actually, just to stay consistent with the notation, I'll write this as f of x is 3x squared. Okay, so we can check that this is working by plugging in some values. So if I plug in 1 for x, I'll get 3 times 1 squared, so that's 3, that's good. Plug in 2, I'll get 3 times 2 squared, well that'd be 3 times 4 is 12. I plug in 3, 3 times 3 squared, 3 times 9 is 27. And lastly, 3 times 4 squared, that's 3 times 16 is 48. So it works. Great. That's going to do it for this question.